Hi, everybody. I'm Tommy Clayton, an OpenSciEd middle school teacher and lesson writer. Today, we are going to take a look at lesson 3 from the unit Forces at a Distance. This is a cool investigation lesson. It is going to really help students puzzle over what's happening between maybe two magnets or a magnet and an iron object. And so this is a lesson that's going to leave students with probably a lot more questions than answers, which is super, super fun. So let's get into it. Let's see a little bit more about how we got here. Take a look at this lesson at a glance, see some key moments, and find out some tips and tricks. So let's remind ourselves how we got here. So we're coming off of lesson 2. Lesson 2 is where we figured out a lot about the magnet, figured out that it can push and pull things that are made of iron, including other magnets. And that the coil seems to act like a magnet when it's hooked up to the battery. So similar to a magnet, it has sides. We can push and pull with that. In this lesson, we're really wondering about well, how does the energy transfer between things that are not touching? And like I said, we're not going to find out a whole lot. We're going to find out more about what it's not in this lesson. So let's take a look at this lesson at a glance. This is a one-day lesson, 5 minutes of prep, which is really nice coming after the last 2 lessons. This is an investigation lesson. There is a teacher demo. There is a little bit of hands-on with the kids, and they're not going to need any devices for this. And there is a magnet and matter setup video that can help you with the small hands-on portion that the kids do have. All right, so let's take a look at this lesson at a glance. So over the course of the one day, there is this bigger chunk where we are going to figure out that air is not involved in the energy transfer. And then we're going to navigate out of this into the next lesson. And we're going to take a look at 2 key moments in this particular lesson. So that next chunk sort of starts at the end of the lesson. That's going to bring us into lesson 4, where we're trying to really figure out what's happening in the space around a magnet. So here's what we're going to figure out. Ultimately, the air has nothing to do with the transfer of energy. In fact, energy can transfer between magnets when there's no matter. And so that's really, really puzzling. But what we're basically doing in this lesson is ruling out what is actually happening. And it's going to help us want to know more about that space around the magnet. So let's take a look at a few key moments in this lesson. So the first is we are going to do essentially 2 different kinds of investigations here. One we're going to do is hands-on, and that's where we want to block the air. So we're going to use a note card, and then we're going to use cardboard, and we're going to put it in between magnets and block the air between them. And we're going to see that, in fact, they still work, and they can still move things. They can still attract things. And so we're pretty confident that maybe the air has nothing to do with it. But then we are wondering what happens if we actually remove the air. And so that's where we're going to watch a video of magnets in a vacuum chamber. And we're going to see that, in fact, they still work even without the air. We're going to make sense of that by writing an argument. So you may recognize this as a CER, where we want to really name our claim about what's happening with the energy between the magnets, and if the air has anything to do with it. We're going to supply some evidence, and that we have 3 sources to pull from. So the note card, the cardboard, and the vacuum chamber video. And then we're going to supply reasoning. And this is where the kids are going to need probably a little bit of support. The part with reasoning is often very challenging for students when they're trying to connect that evidence to that claim. And so where we end up going from here is, after we figured out that the air really has nothing to do with the energy transfer, we want to know more about what's happening around that. So we want to be able to visualize that. So that's what we're going to do in lesson 4 when we investigate the space around the magnet in a whole bunch of different ways. All right, so here's some tips and tricks. So when we're doing that investigation, if you're coming off of the sound unit or the force unit, the kids are going to want to go here. In the sound unit, we figured out that the air is the reason that we can hear sound. The air helps to transfer energy from a vibrating object to our ears. And so it's pretty natural that students are going to have this feeling that the air has something to do with it. In exploring this and exploring magnets, They may have kind of figured this out in an earlier lesson when students were investigating with magnets. They may have already put something between the magnets and noticed it still didn't work. And that's okay if they did. It doesn't ruin anything. Here's where we're just actually collecting that evidence in light of figuring out if the air has anything to do with it. Students may start to use the word magnetic field here. Maybe they have all along, and just let them use it. That's okay. We're not going to define it yet. We're going to define that word in lesson 4. We're going to do a lot of work around magnetic field. So just let it be for now. Let them use the word. It's totally fine. Don't feel the need to define it or add it to the word wall. We're going to do a lot of that work in the next lesson. Okay, so here's where we actually name that the coil is an electromagnet, and we add that to our word wall, and we also identify the magnet as a permanent magnet and add that to the word wall. And that's going to be during the navigation in part 1. When we are designing our investigation, we are going to use words like independent and dependent variable, and those are callback from previous units. We are going to create a poster for this as we're planning our investigation. We're sort of thinking about like all the different outcomes, and we're writing this in the lens of cause and effect. And students have a similar handout that they're going to use when they're working through that investigation. And that is going to do it for us. Come back and take a look at lesson 4. Lesson 4 is a 4-day investigation. We do lots of work around the magnet and the coil to figure out what that feels like. Some really cool stuff happening. So you're definitely going to want to come back and check out that video. Thanks everybody for watching. Talk to you soon.